Now suppose we're plotting against position, so the x-axis measures how far across the wave itself has moved. In this case, we need to keep time fixed. So essentially what we're getting is a snapshot or a freeze frame of exactly what the wave looks like at a particular point in time. So we can think about this as a sort of still photograph, like we can see over here. So this type of graph is useful for looking at how the graph looks like overall. It's good for getting a big overview of what the entire wave's state is at a particular point in time. And so if we can measure certain properties of this graph, we can learn certain things about the wave. In particular, it's possible to measure the wavelength of the wave. If we have a freeze frame of a wave, then all we need to do is measure the distance between two of the repeated patterns. So it's going to be the interval on the x-axis between two crests, or between two troughs, for example. So the frequency can be calculated as long as we know the wave's speed. We can't really capture that with a still photograph, but if we know for other reasons what speed the wave is going at, then if we know its wavelength, we can calculate its frequency, or its period. Plot the displacement against position of two wavelengths of a wave with an amplitude of 1 centimeter and a wavelength of 40 centimeters. It's a bit of a handful. Now, displacement versus position says that we're not plotting anything against time, so we don't need to say how the wave changes. We're simply giving a freeze frame or a snapshot of what the wave appears to look like at a particular point in time, right? So on the x-axis, we'll have where along the wave we are. And so the wavelength there will be 40 centimeters. We're drawing two wavelengths, so the x-axis will have to be at least 80 centimeters long. If our amplitude is 1 centimeter, that means that our maximum displacement away from zero is 1 centimeter up and 1 centimeter down. So our graph looks something like this. We can see that on the x-axis we've moved up from 0 to 80, and it's taken us two wavelengths to do so. One whole wavelength, and then two whole wavelengths. So a wavelength is 40 centimeters. We can see that the displacement of the wave goes all the way up from 0 to 1, and all the way down from 0 to -1.